Hello and welcome to Slooh's latest Clubhouse clip. I'm Eric Edelman, the producer here at Slooh, broadcasting to you live from Smoky Hollow Studios at Slooh HQ in Washington Depot, Connecticut. And we are currently having a live view here from the Canary Islands. And it looks a little interesting. There's a little bit of action happening at the bottom right corner of the screen there. And joining me tonight is going to be Slooh astronomer Bob Berman. And I was wondering, maybe as a first question to you, Bob, I wanted to ask, did we get the timing of the show wrong? Is it currently day in the Canary Islands right now?
It
What's happening?
it looks like that, and it shows how sensitive our wide field equipment is. That's the moon in the sky, and a lot of people don't realize it, but the moon does produce a blue background sky. Just too faint for us usually to see it, but the Slooh cameras on this wide field view see it. There's Arcturus, just proving that it really is night, one of the brightest stars in the sky, just below the center, and the Big Dipper in the upper right. That you just pointed to. So this is the night, but there's the moon, brilliant in the sky.
Uh, I just have to call back to all of our meteor shower shows that we've done in the years past where we use this all sky camera, and so if there's ever even a near full moon, you can see what sort of torture we have to go through to try and get those dim meteor streaks to see through the night sky. And so it's so great that we're upgrading that, and we have our low light equipment that's going to be able to in some way circumvent that is my hope. But yeah, I'll take your word for it that it's night right now, Bob. I might not be fully convinced. That's just too bright for me. I can't even deal with that. But yeah, we're gonna have an interesting night. It looks like the T1 telescope is working right now, so that's another strike for night. So it probably is. We're going to be talking about a really interesting object that has been touring our solar system for a little bit, and it's making a very temporary stay here. I'm talking about Comet Siding Spring, or more technically known as C 2013 A1. And that comet made a very, very spectacular show in October of last year when it went very, very close to Mars. We had a live show about that, and we'll talk about that a little bit later on. But without further ado here, here's the image that we're seeing now of this comet as it's continuing to travel through our solar system, but maybe just a little bit further away than it has been when we were checking up on it months previous. And so here's that
Yep.
live
Oh, and
view
there
right
it is.
here.
There it is. It's lovely. Still lovely.
Right at the bottom middle of the screen, you can see it. There's this tail that's sort of darting out of it just a bit. Uh, do you know how far away from Earth it is at this point, Bob?
Well, I know that it's no, I don't know the exact distance now. It was
Hmm.
never close, at its closest to us, which was
Hmm.
around September 5th. We're talking about more than half a year ago now. It was still about the same distance as Earth is to the sun. It was almost one astronomical unit from Earth. So it never got close to us, and that's why it never was one of those great comets that lights up the sky the way Hale Bopp and Yakutaki did back in 1996 and 97. Of course, we know why we wanted to pay so much attention to it, and that is it was the closest ever comet to come to another planet. And we actually watched it on October 19th as it essentially skimmed past the Martian atmosphere.
It was so incredible to see. Like, that was a really, really great show. And I mean, this comet is continuing to move onwards and outwards through our solar system here. I think at this point it's about double the distance that it was when it was close to Mars in terms of its distance from Earth, but we're still able to see that really significant tail darting out from there, which is quite beautiful. And
It,
this comet really has a long way to go too. Like, we were talking a little bit before the show here, like, where in the world is it going? Is it going to be coming back? There's actually some like conflicting uh, answers to that as we're looking around for that. Could you speak a little towards
Yeah,
that little
because the
Gordian's
comet
knot, Bob?
whipping around the sun now is was discovered in Lepus the bunny rabbit, the constellation just dangling below Orion. Now it's in Draco the dragon, a very far northerly constellation. So it's well placed for we who live in the northern hemisphere, and it's out all night long. And so this is one reason why it's really easy for our Slooh members to image it, to find it. And I love the fact that we can see this faint tail, even though we've got such bright moonlight. The moon's now a waxing gibbous moon, and that usually is when it starts seriously interfering. But look at that; it's really nicely seen. As to your issue about the orbit, when you look up its eccentricity, which tells us the shape of an orbit, we're used to seeing numbers that are less than one, because that means a stretched out ellipse. For example, Venus, the most circular of all orbits, has an eccentricity of 0.007. Eric, you can never forget it because it's 007. That's what Venus is, 007 as an eccentricity. If you got to exactly zero, like the major moons of Jupiter, Io, Europa, Ganymede, Callisto, you have 0.0000, essentially perfectly round orbits. On the other extreme, you get to the most eccentric, that is egg-like, oval, squashed orbits of planets. Mercury is zero point 0.2. The poor demoted planet Pluto is 0.25. That's an orbit that's so eccentric that it would come in towards the sun and then out again at a ratio of 3 to 5. In other words, almost twice as far away at its aphelion, farthest distance, than its close distance. So now you've got a real ellipse, squash ellipse. You get the idea? So as you head towards 0.1, 0.2, 0.3, you get more and more and more stretched out elliptical. Well, this comet manages not even to be zero point 0.9. It's over 1. Its eccentricity is listed as 1.000 something, which means it's not even an ellipse. If this is true, and we're not sure, we need more observations because it's so close to totally stretched out that it may well be a parabola, in which case it ain't never coming back. The sun has captured it, brought it in from the Oort cloud, not even the Kuiper belt, the Oort cloud, which is the spherical halo reservoir, repository of comet debris, just icy balls, really. And only when it comes this close does it start shedding gases. In other words, the ice is sublimate, turned to gas. And so we're talking about something that's whipped around the sun now, is on its way out. And if it is going to come back, a million years wouldn't be too hard to believe, because many think that it may never come back. It doesn't have an orbit that closes in on itself. It's been captured, whisked around, and now it's on a parabolic trip, and it's bye bye for keeps.
Wow. So either way, if it either goes in and doesn't come back out, or if it does come back in again in a million years, we're not going to really see it again after it leaves. Just our generation is not going to have a repeat of comet sighting spring after this. That's
No,
definitely not
and
going to
that
happen.
and that's too bad for its discoverer, Rob McNaught, a fellow that a lovely fellow whom I know, and we visited with him at Siding Spring. In fact, a couple of years ago. He's the nicest guy in the world and has discovered more comets than anyone in history. He found this one. And you're talking about Comet Halley. You're talking about some of the great discoverers of history, Temple and Swift. Comet Swift is dating from the mid 19th century. No, Rob McNaught. I've lost track, but I think it's at least something like 50 comets. And so when he discovered this one, instead of taking the discoverer's name, which is customary, there are already so many Comet McNaughts, including a very brilliant one that was seen in the southern hemisphere just a few years ago, that he named this one after the observatory in which it was found, rather than bestowing his own name on it, even though he was the discoverer. So it's named for the Siding Spring Observatory in Australia. And so there it is, Comet Siding Spring. Since it was found on January 3rd of that year, 2013, it gets an early letter of the alphabet. Comets are named by letters for their discovery, and this is A1. This is early in 2013, although 2014 is when it put on its show, and 2015 right now is when we're enjoying it as it leaves the solar vicinity. A wild thing that members. I'm glad the Slooh members are still looking at this, because we'll never, probably in our lifetime, see a comet pass this close to a planet again. Although we did see a collision, didn't we? Remember, with the Shoemaker-Levy 9? There was way back, you may recall, when you were a little boy, that we had a comet that came so close to Jupiter, broke up into a bunch of pieces, and sent bam, bam, bam pieces of debris onto Jupiter's cloud tops and discolored it. So but other than Jupiter, usually comets don't come that close to planets. Thank goodness, because we wouldn't want one coming this close to Earth.
Oh yeah, and it was, but it was absolutely amazing to see it from Mars. And I have a really fascinating image that Hubble took of Siding Spring at the close approach. But there's something a little interesting about this image, and I wonder if you could comment on that potentially, Bob. That so here we have the Hubble image, we have Siding Spring, and then we have Mars sort of in the bottom right there, but
Beautiful.
it's not necessarily an image per se. It's more of it's a combination of images, because the issue with it is that Siding Spring is 10,000 times dimmer
Times
than
fainter,
Mars
of
is.
course. So you couldn't do the same exposure in the same image, because
Yeah.
Mars, especially at that time, was only about magnitude 1, and the comet was something at that time, if I remember right, something like magnitude 10 or magnitude 9-ish. So a marginal object, even in backyard telescopes, you'd need a fairly good backyard telescope to see it well. So remembering that 5 magnitudes equals 100-fold change of brightness, we're talking about roughly a 10 magnitude difference, or 100 times 100, which is 10,000. Here, we're doing that in our heads. The comet is 10,000 times fainter than Mars when this picture was taken. So, of course, as you're saying, you couldn't get it in the same exposure, because if you expose correctly for the comet, Mars would just be an absolutely burnt out, bright blob that would be blobby in the entire bottom part of the picture. So 2 separate exposures, one of to correctly take Mars. Polar cap looks awfully nice in that, by the way. That's Hubble for you. Nice, sharp
Can't beat it.
image of that polar cap. and then a separate image of Comet Siding Spring, but showing the true separation between them, which is very cool.
Right. Yeah. And so it took the both of those exposures, just put them together, and I have the number here. It's the at its closest approach where it is looking there. It's about a 20th of the apparent diameter as we see it of the moon. It's that close to Mars is how close Siding Spring is getting. It's so remarkable. And you were speaking a bit to that, just the brightness difference is so extreme that if you have both of them in the same image, that it's really it gets a bit ridiculous. And that was actually what happened in our October live show, October 2014, when we were watching in real time this close approach. Is that our observing feed partners around the world were struggling their hardest to deal with this exposure discrepancy. And while it does look interesting, they were able to accomplish some incredible things. And this is actually, I have a video to show you of that Martin Lyons took. Martin Lyons in South Africa, one of our feed partners, who did an amazing job of dealing with this problem itself. And so here, that should be popping up right here. I'll get our faces out of the way as well.
All right, so the bright object is Mars, of course, greatly overexposed. There's Siding Spring. Oh, good, you've marked it off. There's Siding Spring on the right. And as we watch it, we'll see a routine, of course, UFO mothership leaving Mars from the bottom, leaving a trail of the zircon propellant, which, at least in the aliens from the Mu Cephei system, tends to form a complete ring around the antimatter vacuum that propels the ship. You can see it in the bottom, the green alien ship leaving Mars, along with its zircon propellant ring. But let's focus for the moment. Let's not look at the alien ship. Let's look to the right and see Comet Siding Spring as it zooms past Mars, taken by our feed partner. Boy, he did an absolute great job with that, isn't that? Hard not to look at the alien mothership, though, right? Isn't it?
There's so much going on in this image, really, and I'm just astounded. Like, Mars is just so bright, so overexposed, but he still manages to get that faint motion and to pick out that comet during its close approach. And so I think that was a victory for the observers that night. Seeing that happen in real time was so incredible. And of
Fantastic. I
course,
mean, again, a
these
10,000 times fold difference in brightness between Mars and the comet. So our hats off to our feed partner there. And of course, I'm kidding about the alien mothership. That object leaving Mars is instead an enigmatic optical flare or some sort of artifact of the imaging process of trying to use the extreme thing. I don't know exactly how his optics created that particular bit of false image, but it did.
Bob, I have to say, I've never seen somebody flip from conspiracy theorist to NASA scientist so quickly. That was well done. But yeah. If you Slooh members, you have an idea of how that sort of artifact would get into an image like that. Let us know. Let's brainstorm about it. Let's figure it out. This is what we're a community here for. So all this problem solving. But yeah, there's more to see with Siding Spring coming up as well. I just got a note from Observatory engineering community manager Paul Cox, who is mentioning that this Siding Spring comet will be passing by galaxy NGC 5906 in just a couple days. This is an edge-on galaxy. It'll be a nice sight to see, as it's crossed by Mars. Now it's crossing by this object as well. And so we're going to be scheduling missions for that. And so Slooh members can join in on that. We won't be having a live show, but you can check that out as a citizen astronomer. That's an option for you. And there's lots of things to do with Siding Spring. We also, of course, that show that happened in 2014 is going to be made available in the Clubhouse. We're going to be very soon making a new channel that has to do with comets, so that if you're interested in comets, you can look back on lots of different comet shows we've done in the past. We recently made an asteroid channel, and we thought, hey, we'd make a comet channel as well. And so this show from October will be included in that as well. So look forward to that. And of course, I cannot forget to mention that if you are really, really passionate about comets, and there's something that you like to search for, there's something that you like to just go out and explore in the universe, we have our wonderful commentary group in the Clubhouse called CCAT. And so if you go to activities here in the Clubhouse, go to group activities, you can see lots of different featured groups. And one of these is the CAT's Comet Monitoring Group. And so they collect imagery of different comets that are coming around. And so you can be a part of that community if comets are a big thing for you. But yeah, there's lots of comet fun to be had in the Clubhouse, and I hope you'll take part in that. And if comets are a big thing for you, and yeah, this was really fun to sort of look back and have a retrospective on this comet, and also it speaks a little bit towards a very interesting show that we'll be having in just a couple days. While we won't be looking back on sighting spring on April 30th, we'll be looking at Mercury, which is also another very challenging object to image. And right now I'm talking with feed partners and getting to the point where we're going to try and see image Mercury to the best of our ability, and to have a similar adventure that we had here, where how well are we going to get this image to come out? And so we hope you'll join us for our live show about the Messenger mission, which is ending around Mercury in just a couple days. That's going to be a lot of fun as well. And so, yeah, thank you so much for being around. Do you have any sort of last thoughts about sighting spring before it leaves our show and it leaves the solar system and goes wherever it's going?
Well, very, very special. Just when you think you're not going to see anything new, here's a comet that rained bits of debris on our sister planet. Well, I guess Venus is more like generally called our sister planet, but our next planetary neighbor out from us, considering that its atmosphere is so thin, only 1% of ours, nobody was sure whether the debris from this comet, and tons of it wound up on Mars, could actually produce meteors and streaks and visible debris. But if you were on Mars at that time, you would have had quite a show, and we had a show here at Slooh. Man, was that something, watching that comet go past Mars. So it's great to see that our members are still watching it. Still has a tail heading out now in Draco, easily seen. And wow, those Slooh members are they're on the ball as they watch it go by. Next to be seen, maybe a million years from now, and maybe never. Very exciting.
Very well put. Yeah, this is one for the history books, and I'm so glad that you joined us for the show tonight. It's always fun to see you guys wandering around the Clubhouse. And if you have any other thoughts about what you'd like us to cover next, you're welcome to let us know. Leave a comment on the live shows page, or send me a message. Either way. And we'd love to cover what you like to hear about, because this is a passion project that responds to the passions that you have about the universe. And so thank you again so much for joining us, and we hope to see you next time. This has been Bob and Eric for Slooh.
Good night.